Hello all, this is Dr. Ravina Judy Dolly from the Department of ECE, Karunya University. We'll have a simple discussion on a sorting technique using heap sort. So what is heap? Heap is a special tree-based data structure. Now it has two properties which you call it as shape property. What do you mean by shape property? We have a binary tree, that is, it has a root node and two child nodes. Okay, so now this you call it as a complete binary tree. Why? Because you have a root node and two child nodes, a root node and two child nodes. Okay, but this is the exact root, so this is called a complete binary tree. Now what do I mean by incomplete binary tree? So this part has exact child nodes, but here if you see, a child node is missing, so it is called as a missing node, so it is an incomplete binary tree. No, this shape property should be satisfied for a heap. Okay, now coming to another second heap property. Here you have two different types of heap. One you call it as max heap, where the parent node should be greater than the child node. This is my parent node which has 20 and the child node is having 16 and 14. So now you can see this 20 is greater than 16 and 14. So it satisfies this condition. Now if you take this node, you have two child nodes 12 and 10. It is lesser than 16. So 16 is greater than the child, so it complies with the max heap. Now the second type you call it as min heap, where parent node is lesser than the child node. So now the parent node is 1. Here you have two different child nodes 4 and 6, where you can see the parent node lesser than the child nodes. Similarly, here you have two different nodes. This node 4, it has a value 4, is lesser than 7 and 9, so it is called a min heap. So shape property and heap property should be satisfied for a heap. Okay, now what is heap? Heap is a tree based structure. We'll see a sorting technique. Input data, you have 14, 10, 13, 15 and 10. Okay, now how do I write this in heap or form a heap like structure? 14 is written first, next 20, here you write 13, here you write 15 and here you write 10. This is how you form a heap with this input data or input array. Okay, this is an unsorted array. Now you have to sort it either using max heap or min heap method. Okay, so now we are trying in for sorting it in, arranging it in ascending order. Okay, so now this is the heap and this is the data. We'll see. First you are considering this node. So now you can see this root node should be greater than this child node. Your 20 is greater than 14. So actually this node should be greater than the child node. So there is a swap required. So what are you doing? You are swapping it. So 14 and 20 is now swapped to 20 and 14. Okay, so the rest all nodes remains the same. How does your array change now? 20, 14, 13, 15 and 10. Okay, now if you check this node, your 15 is greater than 14. So in max heap it should be the other way. So what should we do? We should swap. So in the next slide we'll be swapping 15 and 14. So it has been swapped now. So now what do we do now? You are finding out the highest value and then you are bringing it to the root node. So what do we do? Swap the last and the first node. Why? Because the first node will have the biggest value or the largest value. Now if I am swapping it, so it comes to the last node, and after it comes to the last node I will remove that node and keep it separately. and it becomes sorted now. So what do I do now? After swapping it, this is my last heap structure. Now what am I trying to do? I am swapping the first node and the last node, 20 and 10. So my 20 comes over here and the 10 goes here. Now what do? I am removing the last node, 20, and I am keeping it aside. Okay, because it is the highest value. Now parent node should be greater than child node. So here if you see 10 and 15, it should be greater. So what do? We have to swap it. So 15 comes over here. So 15 comes here and 10 goes there. And you have a structure 13 and 14. 20 is kept aside. So now if you see this node, 14 is actually greater than this 10. But this should be greater, so a swap is required. So what do? You swap it. So 15, 14, 13 and 10. Now, so your array looks like this. Now what do? You swap the last and the first node. You know now this is the largest value node. So now you are swapping the last node and the first node. What is your last node? 10. What is your first node? 15. Now it is being swapped. So first 10 comes over here and you are removing the last node. So 15 is kept aside. Okay. So now parent node should be greater than child node. So now 14 and 10 has been swapped now. So 14 and 10 are swapped now. Okay. So you know now this is the largest value. So what do you do now? You have to swap the first and the last node. What is our last node? 13. What is our first node? 14. So we are swapping the 14 and 13 now. So first comes 13 and here comes 10, here comes 14, and the 14 is now removed and kept it aside. Okay. So now you have 10 and 13. What do you do now? You know now this is the largest value. So you are swapping. So 13 comes down and 10 stays here. So now your array, it looks like 10. The remaining all 13, 14, 15, 20 comes here. So only one element is left. So now the algorithm ends. So finally you get the sorted list: 10, 13, 14, 15 and 20. Okay. So now algorithm for sorting in increasing order. So build a max heap from the input data. Then the largest item is stored at the root of the heap. After swapping everything, you fix the largest item in the root of the heap. Now replace it with the last item of the heap, so that you can finally reduce the size of the heap by 1, and you can remove the last item and keep it aside. So repeat above steps until the size of the heap is greater than 1. So now at last one structure is only one root node, only one node is there. Until only one node is there, you have to keep on repeating the same steps over and over again, and this is called as heap sort. Hope you understood the technique. See you. Thank you.